In this session, we look at reliability, which is defined as the ability of a product, part, or system to perform its intended function under a prescribed set of conditions. We use probability here. Now, we first review a concept in probability theory. We call that independent event. So what is independent event? Basically, it means that there are two events or more, which one that occurs, it does not have anything to do with others. Okay, so they're independent. Here's rule number 1 from probability. If two or more events are independent and success is designed as a probability that all the events occur, then the probability of success is equal to product of the probabilities of the events. This looks a little long. Let's slow down and look at this. First, there are a set of events, they're independent, which means one happens has nothing to do with another. Okay, or one does not happen has nothing to do with others either. Success is a state. That means, for example, reliability wise, when a product works, we call it a success. Okay, and it is the product, which means we multiply the probability of each event. Let's take a look at a example. Now here comes the example. We have a machine that have two buttons. In order for the machine to function, okay, recall we call this success in the definition of rule 1. Both buttons must work. Okay. In other words, if one of the button fails, then the system fails, the machine fails. One button has a probability of 0.95. Another one has a probability of working of 0.88. So we have two buttons laid like this. So the electricity go from here into button 1, and then get out of button 1, get into button 2, and get out. We want this whole thing works, then we need button A1 work and button 2 work. Okay, now the probability calculation looks like this. The probability we write as a P of machine that works equals to P of button 1 works times P of button 2 works. What does this mean? That means the probability of machine works equals to probability of button 1 works and the probability of button 2 works. Okay, using the rule 1, that is the product of these two probabilities. So probability of button 1 works equals to 0.95. Probability of button 2 works equals to 0.88. We multiply them, we get 0.836. And this is the probability that the whole machine works. You know, sometimes you have a product and it has a certain rate of reliability. Now, if in case that we want to increase the reliability, there are different ways we can do that. Okay, we can buy a more expensive, more reliable product. Or sometimes we can only use this existing product with a certain reliability, but we want to increase the reliability. What are we going to do? We can use an idea, we call that a redundancy. In other words, we have backup components, okay, which is the way that we can increase the reliability. Here's the rule number 2. Use redundancy to increase reliability. Here's an example. Restaurant don't want a power outage. So what they do is they install a generator. the probability that the power line works is 97%. The probability that the generator works is 90%. Any of these two works, the whole system works. Both of these two fail, the system fail. Let's try to calculate the probability of the whole system works. Scenario 1, the power line works when generator went bad. So what's the probability? So if the power line works, the whole system works. The generator in this scenario is a redundancy. Whether or not it works, it does not matter. So the probability of scenario 1 equals the probability of power line works, which we write it as P of power call, which is 0.97%. What about the generator in this case? It's irrelevant as long as the power line works. Okay. So in other words, as long as the power line works, the whole system works. You got power. That's scenario 1. Scenario 2, what if the power line failed? Now in this case, in order to have power, we need the generator works. So what is the probability that the power line fails? It equals to 1 minus the probability of power line works. Okay, 1 minus it is the chance that it will fail. So equals to 1 minus P of power call. We write it this way mathematically, but if you don't like this line here, it does not matter. Now it equals to 1 minus 0.97 equals to 0.03. Okay. That is the probability that the power line fails. We have not considered the generator yet. Okay. Now, what's the probability of scenario 2 here? Power line fails, but the generator works. So we got a power. The probability of scenario 2 equals to probability of power line fails and generator works. Okay, so it equals to 1 minus, formally it is 1 minus P power call, which is here, okay, times P generator equals to 0.03, comes from here, times power 0.9, that is the probability of generator equals to 0.027. This is the probability of scenario 2. The probability that the whole system works, you always got power, equals to the probability of scenario 1 plus the probability of scenario 2. So one scenario works, you got a power, right? So it equals to 0.97 from our early calculation, plus 1 minus 0.97 times 0.9, which is from our early calculation as well, equals to 0.997. So this is scenario 1, this is scenario 2. Formally, we write it this way. This is the probability of scenario 1, which is a P power call, and this part is probability of scenario 2, which is 1 minus P power call times P generator. Let's look at a more complex example. What we're going to learn from here is to use our rule 1 and the rule 2 several times. After this example, you can learn how to break down the big complex system to small systems and work it out. Here's the example. A student takes 3 calculators, okay, 3 calculators to exam. She's afraid that some calculator will fail. Now, calculator 1 has a reliability of 85%. Calculator 2 has a reliability of 80%. Calculator 3 has a reliability of 75%. Okay. Now, only one of them needs to function for her to be able to finish the exam. Here comes a question. What is the probability that she will have a functioning calculator to use when taking her exam? So, in other words, at least one works. What are we going to do actually is to use our rule 1 and rule 2 several times. Now we learn how to put those individual parts into subsystems. In this case, we put Calc 2 and Calc 3. We put them together. This part, we give it a name, subsystem 1. And this part, yellow, we call it subsystem 2. So subsystem 1 is in green, subsystem 2 is in yellow. Okay, now we break down, we regroup the whole system with the 3 parts into 2 parts. Now let's look at the subsystem 1 first. Subsystem 1 actually represents Calc 3 and Calc 2. So any of these 2 works, the subsystem 1 works. What we do is we refer to example 2. The probability of subsystem 1 works equals to probability of Calc 3 works plus the probability of Calc 3 fail but Calc 2 works. So it equals to 0.75, which is the Calc 3 works, plus 1 minus 0.75, which is Calc 3 fails, times 0.8, that's Calc 2 works, equals to 0.95. Now, I'm going through this briefly here. If you need, please go back and review the example 2. This is the same setup as example 2, just a different way of doing calculations. Just a same way doing calculation, just a different probability here. The subsystem 2 is simple. It is basically Calc 1. So probability of subsystem 2 works equals to probability of Calc 1 works equals to 0.85. This is pretty straightforward. Look at the whole system now, which has 2 parts. Subsystem 1, reliability is 95%. Subsystem 2, reliability is 85%. Now the probability of the whole system works, we calculate it as same way as example 2. The probability of the whole system works equals to probability of subsystem 1 works plus subsystem 1 fails, but the subsystem 2 works. Subsystem 1 work equals to 95%. Subsystem 1 fails equals to 1 minus 95%. Subsystem 2 works equals to 85%. The whole thing, when we finish the calculation here, equals to 0.9925. Okay, let's slow down a little bit here. We can break down the whole system, which has many parts, in this case 3, but we can have 5, we can have 10, it doesn't matter. If we have a system with 10 parts, we break down them into 2 parts. And within that 2 parts, we look at a single part. If it has more than 2 parts, we break them down again. Just repeat what we have done here in this example. We break them into subsystems. We have a maximum of 2 subsystems each time. Now, please stop our lecture for a moment and take 20 minutes to do the following in-class exercise. Please use our idea of break down the whole system into 2 subsystems at a time.